We're in the room. Okay, today we're going to go through to IJKL. Sounds like a lot, but in actual fact, a lot of it you can do in your calculator, and it all sort of relates to lines, finding intersections, solving simultaneous equations, which we can do in our calculator. Luke, what can you tell me? What can you tell me about two lines that intersect? What can you tell me about their coordinates at the point they intersect? What do you think?
They're even.
Okay, they're even or they're equal, aren't they? They're equal. So what can you tell me, I guess, if I've got this point here, this point here, what do they have? They have the same what? What's starting with C? What's starting with C?
Coordinate.
Can you say it again, Ezio?
Coordinate.
Coordinates. That's right. Add the S on the end. Okay, they have the same coordinates, don't they? Okay, so they've got the same coordinates on the Cartesian coordinate system. Mr. Descartes, Cartesian is where that comes from. He was a French mathematician. Cartesian coordinate system from Descartes. Descartes. He's a French dude. You can look him up. Okay? He was French. Okay, now at the point of intersection, therefore, we can solve two. If I have two simultaneous equations, all right. Now over here, I guess what you could tell me is that there's a point that we know on this line, and then there's a point we know on this line. I was just going to show, we're going to have a look at this graph here. Now, if I was solving them simultaneously, I could do it one of two ways. I could use my calculator, or I could do it by hand. Now, let's show you method one, which is by hand. Now, method one, which means I've got equation, I guess, method one, and we've got two equations. Now, let's write those equations out. Those equations are going to be, one of them is x plus 2y is equal to 4, and the other one is x minus y is equal to 1. Now we can substitute, you can use substitution and substitute into the other, and basically what we're doing is two equations, two unknowns. So I'm going to have equation 1 and equation 2. But what I'm going to do is in equation 2, you notice that I have an x equals and I have an x equals at the top. So rather than dealing with y's, I'm going to try and eliminate x. Now I can do it a couple of ways. I can subtract equation 1 from equation 2 if you like. That's one way I can do it. That's one way. Now I can, what does that mean? Equation 2 take away equation 1. So x take away x is 0. Minus y minus 2y is minus 3y. And 1 minus 4, minus 3. Have a look at that, because these negatives are going to cancel each other out. And then I can divide both sides by 3, and we're doing this by hand. Y is equal to what? Y is equal to 1. Now what I do is, what do? I then sub that into my equation. Can you just tell me what x is going to be equal to? Let's sub y equals 1 into equation 2. What is that going to give me? X minus 1 is equal to 1. So therefore x is equal to 2. Now that's one method of doing it. That's what we call substitution. Okay? Or sorry, that's called elimination. This method here is called elimination. Okay? Because we're eliminating a variable. Whoops. Let me just, there we go. So this method here was called elimination. Elimination. It's really hard to do it. Okay, it's really hard. Okay, what's going on? What is going on? My thing's packed itself for some reason. Let's see if I can get back into it for some reason. And elimination. Okay. So, we've done elimination. Let's do substitution. Now, what we can do is we can say that equation 2, let's just do it a different way, and rather than using x, let's say that what does y equal from equation 2? If I add y to both sides, what is that going to give me? If I add y to both sides, what I'm going to get? I'm going to get x is equal to y plus 1. Okay, and then what can I do? I want to get y in terms of x, so what do I do to both sides? I subtract 1 from both sides. So therefore, I've got y is equal to x subtract 1. Now what I can do is I can then sub that back into... Now the problem is, don't sub it back into the equation that you use. Which equation we use? We use this one. So which one do you sub it in? The other one. Okay, so what we need to do is we need to sub that into there. So what do I do, Deej? Can you look at that? Look at yellow and pink make what colour? Red. Isn't that amazing? Isn't that cool? Yeah. All right. So wherever there's a y, I'm going to replace y with what? X minus 1. So let's do that. So let's sub that into there. X plus 2, x minus 1 is equal to 4. So this time, rather than finding y first, we're going to find x. I'm going to expand that out. We've got x plus 2 times x is 2x. 2 times negative 1 is negative 2 is equal to 4. I'm going to collect like terms. I've got 1 x-ray and I'm adding 2 x-rays. I've now got 3 x-rays. And then I'm going to get this 2 over to that side, which means we've got 6. X is equal to 2. Isn't that what we got before? It is. Now I have x equals 2. I can sub it into either equation. Let's just sub it into equation 1. 2 plus 2y is equal to 4. Then I'm going to subtract 2 from both sides, which is going to give me 2y is equal to 2. Look at that. Y is equal to 1. So whatever method you use, whether it be elimination or substitution, up to you. They're both equally viable. But remember that we have a calculator. Now there's one of two things. If two lines are parallel, will they ever intersect? No. Think about two tram lines. Two tram lines are never going to intersect because they're parallel. Okay? However, if they are not parallel, eventually they will meet at some point. Okay? Coincidental lines. If two lines are equal, then they intersect at every point. Now that's basically the theory behind 2i. You guys need to solve simultaneous equations and I'd like you to do it by hand. I'm also going to show you how to do it by... Now I've just shown you algebraically. Let's just do one more example just to make sure, because I can show, basically I'll show you the calculator. I've already shown you that before. Was using LinSolve in your calculator. So let's do this one. I'm going to pause this video. I'm going to get you to try to solve this equation by both methods. Substitution on the left, elimination on the right. I'm going to pause the video, and if you're at home watching this on YouTube going, wow, maths is awesome, can you pause the video too and have a go at this problem? Okay, I'm just going to start here. I've just shown you my method of substitution. Now, in this case, I think that substitution might be a little bit harder because elimination, you could actually, now I've got, first of all, equation 1 and equation 2. I've written it out and I'm showing you how a correct working. Now, I've made an adaptation to equation 1 and I've called that 1 dash. What I've done is I've subtracted 2x over here. I've subtracted 2x from both sides, so I'm then getting y in terms of x. Literal equation, basically. So now I've got 3y is equal to 4 subtract 2x. And then what I'm doing is I'm dividing both sides by 3 to get y is equal to 4 minus 2x over 3. Now that's my equation 1 dash. Now if I've changed equation 1 and I'm using substitution, I can't put it back into equation 1. It's just not going to work out. I have to put it into equation 2. So what I've said is I've subbing 1 into 2. So wherever there, if you see over here, wherever there's an x, okay, wherever there's an x, well that stays in an x because we haven't got a literal equation x in terms of y, but we do have y in terms of x. So that's what I've done. I've replaced y in this equation here. I've replaced y with 4 minus 2x over 3. And that's what I've done here. As it turns out, the 3's cancel out, however the negative stays. So we've got x subtract 4, negative 2x is plus 2x is equal to 2. I've rearranged that equation, simple algebra, you could use your calculator too, x is equal to 2. And then finally, to find y, I've then subbed it back into any equation. I've subbed it back into equation 1. Y is therefore equal to 4 minus 2x over 3. But because x is equal to 2, 4 minus 4 is 0. So therefore, x is equal to 2, y is equal to 0. Now, of course, I've shown you how to do it by substitution, and I think personally in this instance, it's harder. If I, however, had two equations, y is equal to 2 minus 3x, and then y is equal to something else, then it's probably best, or if I had y 3x plus y is equal to that, and I had another equation y equals something, then it's probably best to use substitution, because you can just sub in whatever y is into here. But this isn't the case. So I actually think that that's not my preferred method, but you can use either, and either are viable options. All right, but I'm always trying to do what takes the least amount of time. For elimination, we've got equation 1 and equation 2. Equation 1 and equation 2. What I'm going to do is I'm going to add those two equations, because look, the coefficient of y is 3 and minus 3. So if I add equation 1 and 2, 2x plus x is equal to 3x plus y plus 3y, subtract 3y. They're going to cancel each other out. And then we've got 4 plus 2 is equal to 6. So therefore, x is equal to 6 divided by 3, which is equal to 2. And once I have that, I then go ahead and sub that into equation 1 or 2. Let's just say we're going to throw, when x equals 2, we're going to throw that into equation 1. 2 times 2 plus 3y is equal to 4. 2 times 2 is 4, plus 3y is equal to 4. And then I'm going to subtract 4 from both sides. And then that's going to give me the same result. Y is equal to 0. Okay.
Can you do subtraction instead of addition?
Yep, of course you can.
So,
Yep, but the thing is, I would have to subtract 2 from 1. I would have to subtract 1 from 2. So what we could do, Deej, that's a very good question. Can you just ask that again? Can you do
subtraction instead of addition?
Yes, you can. And I'm going to show you. All right? So what we're going to do, though, there's no point adding 1 and 2 together. What we're going to do, though, is which one of these? If I subtract 1 from 2, is that going to work? If I do equation 2, subtract equation 1, is that going to work? Negative 3y, negative 3y. Is that going to work? No, it's going to be negative 6y. Yes?
Can you do 2 from 1? Because then you just get
Yes.
x equals 2.
Well, we could go 1 subtract 2. What's that going to do? That's going to give me negative 3. It's going to give me positive 3y minus, it's not really going to do much. It's going to give me 6y, isn't it? Yeah? So, look, you can teach, but in this instance you can't, because you can only add the positive and the negative, and they're going to cancel each other out. But yes, you can use subtraction, but so it just depends on the situation. All right, now what we're going to do is we're going to solve using a CAS calculator, and it doesn't really matter which one we do. I'm going to pause, and you guys are going to do this one using, now it says here using your solve function. I shown you another way, didn't I? I've shown you menu, algebra, solve system of equations, and we want to do variables x, y. Okay, can I get you, I'm going to pause the video, and can I get you to have a go at that, please, for this one, and away you go. In the room. Okay, now this one, x minus 2y is equal to minus 4. Now it says here you can use your solve function, but yeah, not solve. What are we using? Linsolve. Now you can type in linsolve, but I've already done that for you, and I've found that in my algebra. Oh, it is solve. Okay, but the thing is that to get these variables out, we need to go to menu, algebra, solve system of equations, solve system of linear equations. But I've already got that. So now what we're going to need to do is we need to put in our two equations, which are, what's the first equation? We've got the first equation, x minus 2y is equal to negative 4. So I'm going to put that in. X minus 2y is equal to, where's the equal to sign? I've just lost it today. I need a coffee. And the next one is 3x plus y is equal to 9. And because we've done that and we've added, be careful though, you need to have those variables set up. Can you see here that we have x, y? If you do not have x, y, then it's not going to solve with respect to those. If you have two unknowns, you need how many equations? Shout it out. Two equations. Excellent. I press enter. There you go. X equals 2. Y equals 3. So pretty straightforward. But what you need to do is you need to write out what you're doing in the calculator. Shh. You must show your method. So if you're doing something in your calculator, just doing that you're solving x minus 2y is equal to negative 4, 3x plus y is equal to 9, and I guess you're doing comma x, comma y. That's effectively what you're doing. So x is equal to 2 and y is equal to 3. And sorry, y is equal to 3. All right, and finally, last but not least, is applications of simultaneous equations. Now, we've discussed this again. We've always got to identify our variables with any equation. We've then got to set up the equations by transforming written information into algebraic sentences. Let's start. It's about turning that English into maths. Solving the equations either by substitution or elimination, or of course calculator. And you have to interpret the answer. We've been through this theory before, so I won't go it again. So can you please have a go at this question? Bella, that's the name of my dog, isn't that amazing? Bella and Boris are celebrating their 25th wedding anniversary. Today their combined age is exactly 100. If Boris is 4 years older than Bella, how old is his bride? How many variables or how many unknowns are there? There is 2 variables, which means we need 2 equations. I'd like you to write those equations now. I'm going to pause the video. If you're at home watching this, please do the same. We are back in the room. All right. So, first point I want to make about this is Bella and Boris both start with a B. I would advise not to use big B or little b. Maybe, I'm just going to say, you can use whatever variables you like as long as they're different, but we've got to declare our variables first of all. I'm going to say let x be equal to Bella's age. Thank you. Okay, now let x is equal to Bella's age. And we're going to say what unit it is. It's years. It's not in months. It could be asked in months, but it's not. So we've declared our variable 1, and I'm going to let y is equal to Boris's age. So step 1 is identifying the variables. We have now got 2 variables, and we will have 2 equations. Set up equations by writing in algebraic sentences. So they've got their 25th wedding anniversary. Rubbish. Who cares if it's their 25th anniversary? We couldn't give a hoot about that. Today, their combined age. Well, today, combined age is exactly 100. So what we... So therefore, we can say that x plus y is equal to 100. And we're going to call that... What are we going to do? What are we going to do, Nick? What are you going to do after you've done that? You're going to call that equation...
1.
Equation 1. Can you write a little 1 there next to you? Well, let's show us how good your handwriting is on this thing. That's pretty good. Well done. All right, so he's called it equation 1. And therefore, we've got another one. This is where it becomes trickier. Boris is 4 years older than Bella. Now, remember, Boris is 4 years older than Bella. So if we say that Bella is X, and I add 4 to Bella's age, That is equal to what? Y. That is equation 2. Now, to be honest, if we were doing this by hand, y is equal to x plus 4, and we've got y is equal to y plus x. So what we could do is we could do two methods. We could do substitution, which we could say that let's change 1 to 1 dash, and I'm going to say that y is equal to 100 minus x, subtracting x from both sides. Now, I could then sub equation 1 into equation 2, write out what you're doing, and what that means is wherever there's a y, I can then replace that with 100 minus x, effectively eliminating one of the variables, which means we can solve. So I'm going to do that. Equation 2 is wherever there's a y, I replace with 100 minus x. So 100 minus x is equal to x plus 4. Oh, look at that. We can add x to both sides. Add x to both sides, which is going to be, give me 100 is equal to x plus x is 2x, and we've got plus 4. I then need to subtract 4 from both sides, which is going to give me 96 is equal to 2x, and therefore I could divide both sides by 2. X is equal to 48. Now there's no point telling me what x is, but what is, if Bella's age is 48, given that equation 2 says that Boris is 4 years older than Bella, how old's Boris? 52. Now, do we finish like this? No, because can someone put their hand up and tell me what's the last step? What's the last step? What's the last step?
We need to interpret the question.
In what language? Japanese, Chinese?
English.
In English, thank you. All right. So, therefore, we're not finished yet because it says interpret your answer by referring back to your original problem. That's what it says. So, what's that?
It's just a minus 25 because when she got married. She has to minus 25 because the 23rd anniversary.
Oh. How old was his bride on the day of the wedding? Yes, okay. So we've also got to... So what we can say is that now we can say that Bella is 48, yes? And so I didn't read the question, did I? Thank you, girls. And Boris is 52. So given that their wedding anniversary is... There's a 20... So that was important. Their 25th wedding anniversary. How old was his bride on the day of their wedding? We need to subtract 25. So therefore, Bella was 23. And that's your answer. Okay, are there any questions? IJKL, I've just been through all the theory of that. I could have done that with a calculator if you like. And of course, if I wanted to do it via calculator, I would go to Menu, Algebra, Solve System of Equations, Solve System of Linear Equations, go like that, and I can say y is equal to x plus 4, and then what else did we have? We had x plus y is equal to 100, and look what you get. Oh, is that x plus y? And then... Oh, we need an equal sign. What's going on? I'm getting... And there you go. X is equal to 48. Y is equal to 52. But the calculator is not going to interpret the question, is it? It's not going to say that. That's exactly right. We have to minus 25. All right, so I'm going to stop there. It's a longer video, but that actually covers the rest of the whole topic for Chapter 2. Next week, we'll be covering Chapter 3. I'm going to stop it there. Thanks for your attention.